Hello, today we're going to talk about the importance of graphing. Not graphing in math, but graphing in science, which is a lot different. It's got a lot of the same ideas, graphing paper, straight lines, and all that good stuff, but the how you graph and what you graph is going to be a little bit different. We've learned that using the scientific method, you gather data, and data is so incredibly important because it tells you the results, tells you everything you need to know about the experiment. But a lot of times people get very lazy and they don't want to read through all the data. Well, graphing is a great way to show the results of an experiment quickly, easily, and it's very easy to understand. So let's get into graphing. Now you will be needing graph paper, so if you don't have any, see if you can scrounge some up. If not, I do have some at school. So I chose some graphs here to show you some of the basics that we'll be working with, such as a bar graph, a pie graph, and a line graph. So let's go see what we need to do for graphing. Okay, the two main types of graphs that we're going to be using in science are the line graph and the bar graph. So how do you know when to use which one? Most of the time, you can pretty much guess with most of the time you are going to go with a line graph. So let's take a look at what a line graph does. Line graph is used to track changes over time. That's kind of like your key word right there. Anytime you have dates involved or time, like how long it took for something to grow, or something that happens year after year after year, or the monthly rainfall in an area, those types of things, line graph would be good. Or you can follow changes over the same period of time for different groups. So maybe I'm taking a look at how 3 different plants grew in the same amount of time. I can use that. So it doesn't have to be just one line like this. So usually if you see time involved, it's probably going to be a line graph. If it uses seconds, weeks, months, years, minutes, whatever, it's probably going to be a line graph. Now, a bar graph, the main thing you're going to be looking for here is the word comparison. So that's our keyword for bar graphs. When there is no link between one thing to the next, like in a line graph, there is a link. Like on this graph, it says math score percent, grade level, 7th grade, 8th grade, and so on up to senior year. This all connects because this is the score 7th grade, score 8th grade, score 9th grade. They're all connected. One depends on the previous. Whereas here, favorite type of movie, the number of sci-fi people has nothing to do with the number of drama people. So there's a comparison between distinct groups as opposed to following one throughout time. So for a bar graph, you're going to use that whenever you see a comparison among groups, individuals, or so on. So line graphs, I'd say 90% of the time it's probably going to be a line graph. 10% of the time it'll be a bar graph. So when in doubt, like you just can't figure it out. When in doubt, go with a line graph. And you'll probably be right. But if you're comparing something, that one thing has nothing to do with the other. Like if I were to connect the dots here to here to here, go like that, and then down to that guy, and then up to that guy, well, they have nothing to do with each other. The comedy people and the action people and the romantic people, they have nothing to do with each other, so you don't connect them. Okay? So bar graph, comparison, line graph, usually over time. Okay, what other things are needed for a graph? Well, I've got this kind of basic outline as to what you need to put on a graph. And this is also very good because it'll tell you how you're going to score on a graph, because pretty much each one of these things is a point. So here is graph paper. Okay, that's kind of number one. The reason why it's called a graph is because it goes on graph paper. Okay, that is important concept number one. It's called a graph for a reason. If you do your graph at the bottom of a blank page of paper, like on photocopy paper, if you do it on lined paper, I don't even grade them. I don't even look at them, okay? It needs to go on graph paper. Has to go on graph paper. I will never ever look at a graph unless it's on graph paper. Okay, you got that? Okay, good. Okay, so that's kind of important thing number one, is that it needs to be graph paper. Okay, next thing that's very important is you have your y-axis over here and your x-axis over here. So how do I know what goes where? Well, remember back when we were talking about the scientific method that we had variables, the independent and dependent variable, or responding and manipulated variable. Okay, so on the x-axis on the bottom is always going to be the independent, or what we call the manipulated variable. Manipulated, there we go. So this down here is the thing that you, remember, you're the experimenter, you're the one that, it's the thing you're messing with. So it's what you're changing. So remember with my tortoise, it was the type of flower that was yellow. So down here on the bottom, I would have, you know, flower number 1, flower number 2, flower number 3, flower number 4, and so on. So the thing that I'm messing with goes down here on the x-axis. Now notice also with it, not only do I have the variable, but I have a label and a unit. So let's say, it's not my tortoise example, but something else. And I have the numbers 1, 2, 3, 4, 5, 6, blah, 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 all the way up to, say, 30. Now, unless I tell you what those numbers are, they mean squat. Absolutely nothing. Okay? Is this 1 day, 1 week, 1 month, 1 year? Is it 1 milliliter? Is it 1 kilometer? You don't know. So what you have to do is tell me what it is it's measuring. Okay, so let's say it is time. Okay, I'm measuring time. So that's what the label is what am I measuring? Okay, so that's the label. What am I measuring? I'm measuring time. Okay, and the unit is how. How did I measure time? Okay, so I measured time in seconds. So every x-axis should have the what you're measuring and the how you're measuring. So that's a label and a unit. Okay, so down here you have the independent variable. In this case we'll call it time. We need a label, which is time, and then we need a unit, seconds, days, whatever. Okay, now over here is the dependent variable on the y-axis, which is what we also call the responding variable. This is what we were measuring throughout and during the experiment. So this is what I messed with down here. Over here, this is what I'm measuring during or after the experiment. Okay, so let's say we were measuring the growth of a plant in days. So day 1, day 2, day 3, day 4. Okay. How might I measure that? Would I measure it in miles? No. Would I measure it in microns? No. So what am I measuring? What is my label? Well, I'm measuring growth. And how am I measuring it? I'm measuring it in centimeters. So I need the what and the how. So the label is the what, the unit is the how. I'm measuring the growth of the plant, how, in centimeters. So, and that's what I'm measuring. That's my responding variable. That's what I'm measuring. Okay, so what you're messing with goes here. What you're measuring goes there. Okay, so now we got the X and the Y. Okay, so what are some other things? The descriptive title. This is the one that bugs me most of all. People, for a title, say graph 1 or science graph. No, 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 no. These are not good titles. Okay? A title needs to be descriptive. Usually what you can do to ensure that it is a descriptive title is to include the independent and the dependent variable. And if you get a nice big long sentence, totally cool. They don't have to be 2 or 3 words. I don't know, sometimes you guys get it in your head that graphs titles should only be 2 or 3 words long. No, no, no. You can have 10, 20 words if you want, as long as it describes it. So for some made-up thing, some made-up data, we'll say well, what did we use? We use day down here, and we use centimeters, that's a C, centimeters up here. So the amount of growth of a plant, I can't spell, plant in 30 days. Okay? So I've got a little bit about this. I've got the days, and I got a little bit about this, the growth of the plant. So I've kind of included both. And that's okay. It's totally okay to have a nice big long sentence, because I want to know what my data, if I have a graph that looks like that, I want to know just by reading this alone what this means. I shouldn't have to look at anything else. I shouldn't have to read the little description down below. I should be able to look at the title and go, oh, that's it. I know exactly what that graph says. Okay, another one that should be self-explanatory, but apparently it isn't, is this one. Use a ruler. You have rulers, use them. See all these straight lines right here? They're there for a purpose, because they want straight lines to be drawn on them. So if you're doing one of these plots where you're putting polka dots like this and you have to connect them, don't go like that. Use a ruler. Obviously I can't use a ruler on my little pad here, but use a ruler. If you're making bar charts, use a ruler for all parts of the bar. They should not look like that. Ruler for all 3 sides of your bar, and then you might want to color it in and make it pretty. Now, a lot of people like to use pen, but then you screw up, and then what do? Is you try to go over it with darker pen. That's not good. Use a pencil, so that way when you do mess up, it's easy to fix, and you don't waste a whole piece of paper. Use a pencil, and then when you're done and your graph looks good, and I've checked it, and I go, yep, that's great, then you can go back and color it or do it with pen, but always start in pencil. Okay, some other things about graphs. Say that this is the whole size of your paper. If this is the whole size of your paper, don't use this much of your paper for your graph. Okay? You have a whole sheet for a reason. Use the whole entire sheet. Because what happens on line graphs, if you make your graph really small, it looks like that. Well, that's no good. But if I spread it out, now, look, wow, there's a lot of stuff going on here. So by making it big and spreading it out, I can see much more detail than I can with a little dinky graph like that. So use your whole sheet of paper, okay? And then something else. Well, numbering. The numbers on the side. Each of these boxes need to represent the same numbers apart. So like if you choose this to be 0 and 2, well then that means every single one of these lines should be 2 apart. 4, 6, 8, 10, etc. And again, I know that sounds ridiculous, and you go, of course I know that. But you'd be amazed how many people, if I give them data, so here's the X and here's the Y, and I've got 2, 5, 9, 26, and 32. Okay, you'd be, I couldn't tell you how many people do this. 2, 5, 9, 26, and 32. Well, guess what? If you do that, you will always get a perfectly straight line every single time. Okay? So each of these numbers, you need to find out how to spread it out. So I'm going up to 32. So I want this to be 32. We'll just count out how many lines you have, divide it into 32. And that will tell you exactly how many units to make each of these boxes. Okay? So each box needs to be the same distance, the same numerical unit apart. And then, if need be, a legend on there. So like say you have 2 colors. Say you have one graph showing something like this, and then you have another one that goes like this. Well then I want a legend that tells me the purple line is this, that's orange, and the purple line is this. I want to know what those different lines mean, because again, if you don't label, you don't tell me what it is, it doesn't mean anything. So most of the time, you'll probably need a legend. Okay, so I gave you some examples here. Now, since this is just notes, you can scribble it in your notes, not on graph paper. That's okay. But I want to do this because tomorrow we're going to take a look and see how you guys did. Okay, so here's some sample data. My students' grade on the final last year. So they took the biology final. I took a look at 5 different students. Here, if this helps make it a little bit easier, do that. And this is their grade. We'll say in percent. How would you graph this? First of all, would you make a line graph or would you make a bar graph? Okay, that's the first thing I want you to think about. So if you're not sure, hit pause, think about it, unpause me when you think you got it. Okay? So, pause. Yeah? Okay. So, I've got 5 different students. Okay, there's your first clue. Different students. Okay? How would I do this? I would do a bar graph. So let's take a look at what this would look like. Okay, so I got student 1, 2, 3, 4, 5. So would that go on the Y or would that go on the X? That would go on the X. So here's student 1, student 2, student 3, student 4, and student 5. Okay, let me scoot back there. So we got 95, 59, 83. Hold on. 95, 59, 83. Let me get the other two. 72 and 25. Ooh, they didn't do so well. Okay, so here's this. So what's going to go here then? Well, obviously the grades. Now, am I going to do 25, 59? No. I got to figure out some intervals. So let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. So student 1 got a 95. So student 1, 95. And I'm going to put a little thing right there. And then I'm going to use my ruler, if I had one, to draw this all the way down. And then I would color it in. Okay, so there's student 1. Did really, really good. Okay, student number 2, I'm going to use a different color here. Student 2 got a 59. So I'm going to go up to 59, which is right close to 60. And I'm going to color that one. Okay, there's student 2. Student 3 got an 83 on the final, so somewhere right around there. Okay, I know this is kind of messy. You guys would make this look nice. Student number 4 got a 75, so right about there. And color that in. And the last one, student number 5, ooh, got a 25. That's not good. And we color that in. Okay, so what am I missing on this graph? A couple of things. I need a title. So, final grades of 5 students. Of what? 5 students in bio final. There we go. Now it's much more complete. Okay, what am I measuring down here? I'm measuring the students. Okay, now you don't need a unit on this one because we know that a student, the unit is the student, the individual person. So we don't need units down here. But over here, what are these numbers? That's their grade. How is it measured in percent? So I've got the what am I measuring and the how did I measure it. Okay? So now I've got the basics of a bar graph. I've got my 5 different students. I can see how they did. So we can see these 3 students here did well. These 2 students not so well. And there you go. You got a bar graph. Fairly simple. Another thing I could do, I can add a legend over here on the side and put, color code it. Student number 1, student number 2, color code it. I could put a legend over there if I'd like. Okay, well this kind of gives away what my next question is going to be. If this is my next data, what would the graph be on there? So I've got student X, so that's one person over 4 years. So I'm looking at one person over 4 years. So 9th grade in science, they got an 85. 10th grade, they got a 71. 11th grade, a 91. 12th grade, 78. How would we graph that? So, okay, 85, 71, 85, 71, 91, I forgot the last one, and 78. Okay, so how would I graph this? Would the scores go here or here? Well, we're measuring the person, so the student X would go, actually no, I'm sorry. Let me try that again. Okay, so what would go down here is because we're measuring them over time, this would actually be time here. And we're measuring them, their grade level. So 9th grade, 10th grade, 11th grade, 12th grade. Okay, and then over here would be just like before. So 100%, 90, 80, 70, 60, blah, 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 all the way down. Okay, so 9th grade, what did they get? They got an 85. So now, I'm not going to make a bar graph because remember that they continue off of each other. So I'm actually going to put a dot We're 85. Okay, that's a really big dot. Let me make a smaller dot, because I know some of you, that's driving you crazy. Okay, so she got a 85 freshman year. Sophomore year, 71. 11th grade, a 91. And then down here we get a 78. Okay, so now I would use a ruler to connect the dots like this so I can see her grade is fluctuating from one year to the next. So now what do I need? I need a title. So we have student X's science grade through high school. Now I'm abbreviating. You would write this all out because I've noticed it's 20 minutes now and I'm sorry. Okay, so student X's science grade through high school. What would be over here? Grade. How is it measured? Percent. Down here, what did we measure? Time. And how? By grade level. We don't need a legend because we only have one thing we're looking at is one individual student. And so other than that, that's pretty much all we would need. Okay? So I know this is a lot to throw at you right away, so don't worry. We are going to practice this lots and lots and lots. So tomorrow I'm going to give you just tons of data, and you guys are going to practice graphing and making sure that you get all the different bits and pieces in there. So that way for the rest of the school year, anytime you have a graph that you have to do, you'll get full credit on it. Okay? So thank you guys. Sorry I took so long on this one, and I will talk to you tomorrow. Bye-bye.